we are dealing with motion, and in this case it's in two dimensions. You'll notice that I've got a horizontal component and I've got a vertical component. When we're dealing with vectors in two dimensions, it's often convenient to break them into two components, and we'll see why. If I were to consider the velocity of the cannon shell right when it's fired, I could actually break it up into a vertical component and a horizontal component of velocity. As you can see, when I've broken it up into these two components, when I add them together, they're equal to the total velocity. And so I'm just going to label these VH, V sub H, and V sub V. And so breaking them into components is fairly simple because really it's just a right-angled triangle in the long run. Now the reason we break them into these components is because each of these components behaves quite differently. And so your first question, here's my total vector, here are my component vectors. What does the horizontal velocity vector, in other words, the one that looks like this right when the shell fires, what does that look like when the shell reaches the apogee of this flight? Does it look just like it did before, as in example A? Has it changed? Has it become this angular vector? Is it up? Is it down? And so which of these vectors is the horizontal vector going to look like?